In the last 40 years, most loss of life related to geohazards has happened in Asia. So our main mission is to understand the geohazards that confront Southeast Asian communities, either the dramatic events like volcanic eruptions or earthquakes or tsunamis, or the slowly creeping events like climate change and sea level rise. Somewhere along the line, maybe 50% of Southeast Asia is going to experience a horrific event. But it might not happen here for 500 years. It might happen over there tomorrow. One thing I do say to the people on the west coast of Sumatra is, you should expect your children will experience a great earthquake and the tsunami that comes with it. So what do you do when you feel a big earthquake? You watch the sea recede, or do you run for the hills as soon as you can? There are 200 or so active volcanoes in Asia. Over the next 10, 20, 30 years, we hope to be able to say these 3 volcanoes are big enough when they go that they could actually change climate and that we need to worry about in terms of food security.
It is likely that the biggest threat would be from Sumatran volcanoes. So what can we learn from what they've done in the past in order to be better prepared in the future? I work with samples after an eruption, so I make some sort of an autopsy. So that one of the goals of my research is to develop tools that would enable us to have a better grasp about which volcanoes in Sumatra are actually likely to be a threat and which are not.
I look at what is the history of the ocean and how has it changed its behavior during times of climate change. We look at fossils, and in those shells, there is a chemical signature based on temperature or based on precipitation at the time the shell was formed. If we have changes to the ocean system, populations are very densely populated along low-lying coasts. So understanding how those systems have worked for the past 500 years is going to be really critical to understanding how they might react in the next 500 years.
We put GPS receivers all over a region that's deforming. They're bolted to the rock and they're measuring their position every second. So we can build up a picture of the deformations of the Earth's crust. You've got the Indian-Australian tectonic plate diving underneath Sumatra, and in a place where it gets stuck, you would see that GPS station being dragged down towards Singapore. What you would see if there was an earthquake is it pop right back up. If there's a big earthquake, then Singapore could actually sink a little bit, raising sea levels.
What people care about at EOS is teaching and giving back to the community. So we have Singaporean students and students from Indonesia, Malaysia, Vietnam, and China. They can share what the challenges are in their countries, and they are more likely to have a better understanding of a major storm or a big tsunami that really influences people they know.
With natural hazards, having knowledge is a very important factor for saving lives. Our audience are the regular average people who live in the villages or cities who need to know some basic information to help them survive a catastrophe. We make entertaining games or movies or books that the average person can learn from, so the next time a big hazard hits, people know what to do.
If you don't pay attention to what Mother Nature has done in the past, you or your progeny are bound to suffer again the same fate. So there's a long-term political and economic and social value to having earth scientists tell people how the world works.